problem, all of you? See, whenever you get this, no, you tell me. It's blocking my view. Okay. Yesterday recording many times, it has come. Blocking. Aram say, study the problem carefully and solve this. Sorry. Problem. So suppose all of you understood this problem. Somebody who has captured this problem well can tell me, so that like yesterday, we'll convert the information that is given here or the data that is given here into a format which will help us to get the solution to this problem. No clue? Anybody, please?
Sir.
Yes.
Sir, now the wheel or pulley is, it starts rotating, sir. And it is accelerated, sir, at the rate of 0.8 radian per second square.
Okay, you don't describe the data there. No, describe the data. I want you to capture the physics.
Yes, sir. So since it's accelerating, sir, it also accelerates the belt which is wound around it, sir, and this acceleration is transferred to that of the wheel B, sir, which causes the wheel to accelerate until it acquires an angular velocity of 10 radians per second.
No, see, supposing you have to solve this problem, how would you go about solving it? I'm sure you would be making some noting here. Okay, so the first noting is RA. Start writing here. You start making the noting here, right? That is, you will identify the physical variables and start writing the physical variables. So RA is given, RB is given. Okay, then what else is given? The pulley is driven by constant angular acceleration, pulley A. So alpha A is given. Okay, and then until pulley B gets the final velocity, final angular velocity of B, omega B, they have given final angular velocity. The belt does not slip. These are, see, I just listed these variables. Hello, are you with me?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So they have asked us to find the acceleration of C. Acceleration of C is to be found out. Okay. See, this is given, this is given, this is given, this is given. I would always, advise you to write it down like this. And AC is to be found out. Okay. Find the acceleration of point C on the belt and angular acceleration of P. Okay. Then they are asking you angular acceleration P. This is to be found out at the first instance. Then how long after the pulley B achieves angular velocity? How long after the pulley achieve angular velocity of radians 10? So they are asking you the time taken for it to achieve 10.
Yes.
So these are the quantities that they are asking with this data. Right? Hello.
Yes.
Now, when you have done something like this, you have to see what is common between the two. See, there are two systems. The two pulleys are moving and this is a belt. What is common between the two?
Same acceleration.
The acceleration of
Belt. Yes.
Acceleration of belt is common. The acceleration of belt is acceleration of belt. Belt acceleration.
Acceleration of
it is also the acceleration of the tangential acceleration.
Yeah. Okay. Fine. So yes. So you are identifying the tangential acceleration. Okay. Fine. Now, fine. That's a good thought. I would rather go bit like this. That is the velocity of the belt. The velocity of the belt is equal to the speed of the belt is equal to the speed of the disc. That is the circumferential speed of the disc, not the angular speed. Circumferential speed of the disc. Okay. That is, you see here, this one. Okay, it's like this. So this is the speed. The speed here is v. Therefore, the speed here is also v. The speed here is also v. The speed here is also v.
yes. At an instant.
Hello, at any instant of time.
Yes, sir.
Isn't it? So you see, when the problem is given like this, you see these are the things. And it is, I mean, this is my view. So then this v will be equal to omega a Ra, and this is equal to omega b into Rb.
Yes, sir.
This is the basic equation. Now, if you differentiate this equation, you will straight away get acceleration of the belt. Okay, acceleration of the belt, and you will get alpha a Ra is equal to alpha b Rb.
Yes, sir.
I suppose you understood this.
Yes, sir.
So
Yes, sir.
d omega by dt is this, right? So you straight away get all these equations. All right. Now, having come to this point, now you see what are the quantities that get because Ra is given, right? And Rb is given, right? Then alpha a is also given.
So when I find alpha,
Okay, alpha a is given, and therefore from this equation you can directly get AC here. That is, they have asked for AC, and you will also determine alpha b here.
Yes, sir.
Correct?
Yes.
So what is the value of AC that you get here? Alpha a. Alpha a is 0.8.
0.8 to 50.
And into 50 centimeters. They give you 50 centimeters there.
Yes, sir. For pulling is 50.
0.5.
0.5.
So you take it as half, right? That is half meter. So that gives you 0.4 meters per second. Sorry, per second.
Second square.
Yes, sir.
Is that clear?
No, sir, correct, sir.
Radian meter per second.
Sir, radian is dimensionless.
Correct, sir. Meter per second.
Fine. See, I am getting here AC, man. AC.
That's a part of thing about that. Like 0.8 when you will calculate using the units, no, sir, radian per second square into meter. So it will be radian meter per second square.
Radian meter ಕೊಡುದಿಲ್ಲ. Radian per second square.
Radian meter.
Sir.
How the units are getting cancelled?
Wait a minute. This is radian per second square into meter. So radian meter per second square. You are right. Okay, radian meter per second square. Now tell me, how will you resolve this?
Sir, radian is dimensionless. Yes, sir.
Consider radian.
Radian is L by R, no, sir. So we can write in terms of length in this.
So if it was matter, sir, then why they would give angular acceleration as 0.8 per radian per second? So they would have given only 0.8 per second for this.
So with radian, we can write this.
For that radius, it's length per radian, sir. The radius.
See,
Yes, sir.
radian is what? It is L by R.
See,
Yes,
Is it L by R? So you get, you see here, this is radian. Radian itself, we are defining it also, it is unitless, dimensionless. So what you are seeing here is that you know that whatever is the acceleration at this point, wait a minute. Sorry. Sir, one second, the system is slow here. I think what ohms it is correct. Hello. Can you hear me?
Yes, sir. Yes, sir.
Yes.
Okay. I'm not able to hear you. Come on. Om, what did you say? Om, what did you say?
Radius we can also take it as length per radian also. So the radian will cancel.
Radian will cancel. Okay, so that is what you want to take. So, except the month, everybody agree that this is what you are going to get?
Yes. Yes, sir. Yes, sir.
See, now, Deepak, you see, what is it here? You have got alpha and you have got r, okay? So, alpha into r, what will you get? You will get the tangential acceleration. I hope you remember that.
Yes, sir. Yes, sir.
That's how we did know. The acceleration of a body moving in a circular motion, its acceleration, if you split it into two components, what are the two components? One is radial, one is tangential.
Yes, sir. Yes, sir.
So what is the tangential one? It is alpha into alpha cross r.
Yes, sir.
And if angle between them is 90, then it is simply alpha r.
Okay, sir.
That
Yes,
is how we
I
are.
got- I
Good,
understand.
good. So I hope all of you got this AC here.
Yes, sir.
Right. Now, can you determine from this alpha b?
Yes, sir.
Once you get alpha b, then the next task is to get alpha b. You can get it from this equation. So please get alpha b.
0.5 radian per second. Yes, sir. 0.5 radian.
Alpha b you got it as alpha b. You will get it as 0.5 radians
Radian per second.
per second. Correct? Right. Then time taken for this to achieve its target. What is the target? It is velocity of 10 radians per
10 radians.
10 radians per second, isn't it? So 10 radians per second, omega is equal to omega naught plus alpha. Alpha.
Yes, sir.
So here omega naught you will take it as 0.
0.
So alpha b there is here. Alpha b just now found out. Alpha b into so yes. So
20 seconds.
you get 20 seconds.
Yes, sir.
20 seconds.
So you are using your omega is equal to omega naught plus
Alpha.
omega b is equal to alpha b into t. So therefore t will be equal to omega b is 10, alpha b you got it as 0.5. So therefore this is equal to 20 seconds. Right?
Yes.
And then what else? How long of this one? Yes, I think all the things are spoken. Okay, you understood all of you?
Yes, sir. Yes, sir.
See,
Yes, sir.
these steps are all very trivial steps, not very important. But what is important is in this system, you have to identify the mechanism. Okay? Yes, you identified acceleration is this one. Fine, that's also done. Okay? But my take is I would have rather taken it like this and then proceeded. Because from the basic equation, you can see the things growing. Okay? So now in the first attempt itself, I was able to identify V and life becomes jingala. Okay? But the question is, you should identify this V. There is no shortcut method for that. See, nowhere in the examination they will tell you, oh, see, the common thing between the two is V. Take that. Nobody is going to tell. That should come. So you have to understand the mechanism, apply yourself and get good. Clear to everyone?
Yes, sir. Yes, sir.
Great students. Okay, so we move on. Yeah, so all of you would like to have a glimpse of the answer. You can get the glimpse of the answer. Just to make sure that we have gone the right way. So we got AC 0.5 and we got alpha C 0.4, alpha B as AC as 0.4, alpha B is 0.5 and this we got 20 seconds. Okay friends?
Yes, sir.
Yes.
Yes, sir.
And as you have rightly taken, directly AC is equal to alpha A RA is taken. So you are one step ahead. So you saved one step. Good. So you see, there are different ways by which we can